Last episode, token classification picked one label per token. Every word got its own little tag, org, LOC, or nothing. Question answering does something narrower and sharper. Instead of labeling everything, it picks exactly two tokens, a start and an end, and brackets the answer that sits between them. You hand it a question and a paragraph of context, and it points. The answer is right here from this word to that word. It never writes a new sentence. It never paraphrases, it just finds the span that already exists inside the text you gave it. That's why we call it extractive QA. The answer is extracted, not generated. So picture the setup. You're not asking the model to know things from memory. You give it two things together, a question and a context, a chunk of text that contains the answer somewhere inside it. When was Linux released? Plus a paragraph about Linus Torvalds. The model's whole job is to read that paragraph and put its finger on the exact words that answer your question. If the answer isn't in the context, a good QA model can even say so. Everything it returns comes from the context, never from thin air. Here's the clever trick that makes it work. The model doesn't output the answer text directly. For every single token in the context, it produces two numbers, a start score, how likely is this token to be where the answer begins, and an end score, how likely is this the token where the answer ends. So a 100 token paragraph gives you 100 start scores and 100 end scores. Two parallel streams of confidence, one running over every word. Those raw scores are the start logits and end logits. Think of two bar charts laid over the paragraph. The start logit chart spikes tall at one word, the word where the answer kicks off. The end logit chart spikes tall at another word, where it stops. Everywhere else the bars are low. The model is quietly shouting, begin here at one spot and finish here at another, and staying quiet over the rest. To turn those two spikes into one answer, the model finds the best pair. It looks for the start token and the end token that together score highest. With one sensible rule, the end can't come before the start. You can't finish before you begin. It scans the valid pairs, multiplies the start probability by the end probability, and the winning pair brackets your answer span, start token, end token, and everything in between. That's the answer. But the model thinks in tokens and you want characters. The span it found is token 38 through token 40. Useless to a human, so the pipeline maps those token positions back to character offsets in your original string, start 142 and 149, and slices the substring straight out of the context. That offset mapping is why the answer you get back is the exact text, capitalization and spacing intact, not a retyped approximation. And it hands you a confidence score. That score is just the start probability times the end probability for the winning pair. One number telling you how sure the model is that this is the right span. 0.97 means very sure. A low score is your signal that the answer might not really be in the context or the question was a bad fit. One file does all of this for you in a single call. No logit math by hand. The one catch worth knowing, context can be longer than the model's window. A model that handles 384 tokens can't read a 2000 token article in 1 byte. The pipeline handles this by sliding a window across the long context in overlapping chunks, running QA on each, and keeping the best scoring span across all of them. You don't manage that, you just pass the long string and trust the pipeline to stitch it together. For our example, one paragraph fits in one window, so it's clean. Now the file. It's one script, 13QA.py, and it lands on 3 short pages. Page 1 builds the QA pipeline and defines our question and context. Page 2 runs it and reads back the span, the score, and the character offsets. Page 3 does it twice more, a second question on the same paragraph, and one where the answer simply isn't there. So you can watch the score behave. Page 1 is the setup. We import pipeline from transformers, then build a question answering pipeline pinned to Distilbit base cased distilled squad, a small fast model fine-tuned on squad, the classic QA dataset. Then we write our question and our context as plain strings. The context is a short paragraph about Linux. The question asks when it was released. 2 strings, that's the entire input. Notice we never touch tokenization or LoRA ourselves. The pipeline owns all of it. Page 2 runs it and reads the result. We call the pipeline with question and context as keyword arguments and get back a single dictionary. We pull out 4 fields: answer, the extracted text, score, the confidence, and start and end the character offsets into the context. We print them, then, to prove the offsets are real, we slice context, start to end ourselves, and confirm it matches the returned answer exactly. Same string, both ways, that's the offset mapping working. Page 3 shows the behavior, not just the happy path. We ask a second question on the same paragraph. Who created Linux? And get a different span with its own high score, no reloading, no retokenizing. Then we ask something the paragraph never answers. What is the price of Linux? And watch the score crater. That low number is the whole lesson. The confidence score isn't decoration. It's how you know whether to trust the span at all. So far, every task we've run leaned on a head that was fine-tuned for that exact job. Sentiment, entities, spans. Next episode flips that. We classify text against labels the model has never been trained on, with 0 examples and no fine-tuning at all.